Okay, ji. Bismillahirrahmanirrahim. Let's start with this new topic, and the topic is equivalence of states. And this is the topic that we are now going to start after the midterm examination. So, so the topic is equivalence of states. So, in this topic, there is a concept of distinguishable states. And if the states are distinguishable, then it means that we cannot merge them. And if the states are indistinguishable or non distinguishable, then it means that we can merge them. So let's start to go into a little bit detail about this topic. So suppose you are given with two states P and Q, which are belonging to a bigger set of states, which is Q, which is for the DFA, you can say. Then if P is a final state F and Q is not a final state, which means Q not equal to F. So Q is not a final state, but P is a final state, which means you have two states P and Q, and one is final state, other is not, other is a normal state. Then it means that the two states are different. Or you can say that P and Q are distinguishable in terms of theory of automata. And if they are distinguishable, if they have the different status, one is a normal state and the other one is a final state, which is from the set of acceptance states. So in this way you cannot merge a final state with the normal state. Uh, and if P and Q are non-distinguishable or indistinguishable, or you can say uh, are not same thing, which you can say that P and Q are not different, which in other words, if P and Q are having the same status, if P and Q have the same normal states, or if P and Q have this the status of final states actually, then then you can say that these states are non-distinguishable. And if these states are non-distinguishable, then we can merge them. So then we can merge them. For example, if there is a something. Okay, let's start again. So if the two states are non-distinguishable, then I said that we can merge them. And if we can merge them, then it means that they are indistinguishable states and having either and lying either in the category of final states or lying in the category of non-final states. So these two rules you have to keep in your mind always. So now we are going to, and this is something, these 2 points are something defining the equivalence of states. What what are the states you can say that these are equivalent states? So for example, if the given states are only final states, then those states are equivalent states. And similarly, if the states given to you are non-final states, then you can say that these states are non equivalent states in terms of its status, and that status is non-final states. So now we are going to see an example, and this concept of equivalent states is used to minimize the DFA. That DFA will be given to us, and then we will apply the algorithm of equivalence of states that is mentioned as ES. And after the application of this algorithm, what we will get a minimized DFA or optimal minimized DFA. So here is a DFA given to us, starting state A. After taking 0 and 1, it is going towards B and C. and from B, after taking 0 and 1, it is going towards E, which is a final state, or and D, which is some normal state or non-final state. Same is the case from C, and after taking 0 from C, it is going to a final state F. So E and F are two final states here, and the rest of the states are the non-final states. And now what we have to do here in this topic, so we have to build a n cross n step table. Here I have how many states? One, two, three, four, five, six. So from A to F, I have states from A to F. So you have to write this thing. It is something, the table which is mentioned here is not according to this table, so you don't worry. So suppose if you have the states from A to B, then what you have to write A, B, C, D, and E, and similarly you have to repeat those states in horizontal direction. And then you have to cut the things from the diagonal, and you have to cut all the cells in the upper direction from the diagonal. And there is a reason to remove these or to cut these cells, because these cells are repeated. How? For example, here it is written as BD equivalent to DB. So for example, we are considering something from here. So this BD, I can use the uh, annotation. So this is one thing as a BD, and here if there is no removal of these cells performed yet, then again you will see this is BD, and when you will process further steps, then you will have the D and the B here. So this BD and DB are basically something repeated cells. So BD, as BD is equal to DB, so that's why this is something we can say that it is something repetition. And just we want to repeat these things. So sorry, we don't want to keep these repeated things. So that's why you have to cut the things from the diagonal. And diagonal is also something, for example, this double A is equal to single A, which means this is the rule actually. So if I have, for example, A and A, so this double A is something equal to A, so we don't need this, because we cannot conclude something from this according to the equivalence of states. So again, you have to keep these two things in your mind before solving these type of questions of minimizing a DFA. What you have to do, you have to build a n cross n step table. What is n? N is the number of states in a given DFA. And then after that, you have to remove the cells from the diagonal to upward, which means that the upper side of the table from the diagonal is not needed. So now let's move on. I can clear this drawing, and I can close this annotation, and I can move on. So now, so after removal of these things, what I have left with, this cell which is AA is removed. So what is left from B, C, D, E and A, B, C, D? I have this table left with. So B, C, D, E, A, B, C, D. So this is basically the table uh, which will be in your custody, you can say, or which you have to process after this thing. I have again mentioned B and D. So for example, A, B, C, D. So D and B, these cells, I have mentioned this area. I have mentioned again. I have mentioned this area. Where is the annotation? Okay, this is the. So I have mentioned this area, here in this table, which you have to remove again. Actually, you don't have to consider this area actually, according to the table. Again, I mentioned some cells here, but you know that we don't have to consider these ones. So anyhow, you have to build a n cross n table, that is called step table. And after building that table, then you can start uh, applying uh, the algorithm of equivalence of states. And what is that algorithm? There are steps actually. The step zero is something, a kind of initialization, and after that you have to go on with iteration again and again until you have some cells, uh, which are, you can say, which are unmarked, until you will get a status in which you have your iteration complete, but you didn't mark any cell in that iteration. So that would be the um, final step actually. So I am again repeating these steps. Step zero is basically the initialization that you can do by simply looking at the states, and then you have to conclude that either the merge is possible or not, and based on this decision you have to mark something here in this table. And after that, uh, if you marked some cells in your step 0, then step 2 is needed, and you will perform that step 2 or step 1 here. And if you will get some cells again in a step 1, like here x1 is for the step 1, x0 is for step 0, x2 is for step 2. So if in step 1 you will again mark some cells, then it means uh, that you have marked some cells, and further step 2 is needed. And then you will perform the next step, and you will keep on doing these steps again and again until you will have a situation like this. Here, for example, here this is step 3, and all these things are checked, and we didn't see anything that there is no x3 here. All the things are question mark. And when there is a situation like this, then you can say that okay, we don't have any marked uh, cells in the table, and now this is our termination condition. Then you can terminate, and you can consider these states, which means that you can merge these states. This would be your decision actually. And after merging those states, then you will have your minimized DFA. So this is something we are going to study. So okay, so now I am going to read this step 0, and after that I will apply this step 0, which is some kind of initialization step. So we mark the cells with x0, which cannot be merged. So the cells which cannot be merged, you have to mark those cells as per rules of equivalence of states. Yes, these are the rules, the two rules that you have seen here. That if the states are different or distinguishable, then it is a condition that you cannot merge them. And if they are indistinguishable, then we can merge them. So okay, then you have to see that from here, you can start from here, from the bottom, and from the left bottom column you can start it. You can check that a. So now you can consider this diagram. Only E and F are the final states. Rest of the states are non-final states. Final states can merge with each other, and non-final states can merge with each other. This is something we know according to these rules. Okay, so A is a non-final state and F is a final state. So can I merge this non-final state with the final state? No. So these states cannot be merged, and it is my step 0. So I can mark it with x0. And similarly, I will check that this B can be merged with F. So you can check this with this diagram, B and F. So this is B non-final, this is F final, so they cannot be merged. So that's why you have to mark this cell with X0. Similarly, C and F, these are indistinguishable states. Uh, Sorry, these are something distinguishable states. So I have, and these states cannot be merged. So I have to mark it with X0. Similarly, for D and F, these states are again cannot be merged. So I have to mark it with X0. I can go on horizontally or I can go on vertically. Normally, the algorithm goes on vertically, so it is up to you actually. This is not a big difference actually. So then you have to check that this A can be merged with E. E is a final state and A is a non-final state, so cannot be merged. So that's why in your first step you have to check all these cells. So you have to check. Here I have uh, uh, ignored or I have removed these cells because it is something lying in the category of repetition. So that's why it is removed. So, and A and E cannot be merged. So this is my step 0 going on until I will check all the cells which are uh, which are something I didn't remove from this table. So A and F cannot be merged, so mark it with X0. So this is my step 0 actually. B and F, yeah, or you can check simply here. A and D, A and D are something, A and D are something, A and D are non-final states. So can be merged. So I have to keep it blank. This is something, the answer, um, complete answer. So what I can do, I can just pause the recording and I can use the board actually. Then you will understand these things. So, okay, now I have this board and then I am going to solve this question from the very beginning when we are given with the diagram. So now on the screen, you can say we are given with this diagram and here I have states A, B, C, D. So I can write A, B, C, D, E, and F. Hope you are able to see this thing. So then I can draw the lines. And after that, oh, I don't have space left for the horizontal thing. So I have to redesign this table. Maybe I can go on with like this. So, so first you have to write a, okay, from here. I can leave some space for the horizontal things and then I can leave some space for the vertical things and the horizontal things. Okay, then I can write something here as A, B, C, D, E, and F. And similarly, A, B, C, D, E, and F. And then I can draw the vertical lines speedily and also from here. Now I know that I don't have to consider the diagonals. So from here, I don't have to consider these things, and then I can remove these things. This is something not needed because it is something repetition. So it is something repetition, and I don't need that. You can simply you can simply remove those things, and now you have your table. So now there is no cell remained here, so you can also remove this one because there is no cell here. And similarly, this should be removed, I think. Yes. So there is no cell here because this is something labeled, so I have to remove this one also because now this is the table you have according to that diagram. And now I am going to perform the step 0. I am going to perform the step 0. I don't know, maybe I have to pause the recording and I have to lighten up these things further. Okay, so I am going to perform step 0. What is step 0? You have to check these states. You have to check these states vertically with each other. And if both states are final state, then it means that we can merge them. If both states are non-final state, then it also means that we can merge them. But if the category of state is different, then it means that we cannot merge them. And when you don't have this capacity to merge those states, then you have to mark those states. And this is my step 0, so I can mark it with x0 or with 1. So it is up to you. So, okay. So A and F. F is a final state according to the diagram, and E is also the final state. So I can also mark it with these are the final states. These are the final states. For my guidance, I can mark these so that you will understand. So A and F, these both are distinguishable state, different states. So I can, and cannot be merged. So okay, I can mark it with x0. Similarly, A and E, so different, distinguishable. So I can mark it with x0. A and D, so these are not distinguishable. So these can be merged. So I can left this cell. I cannot mark. A and C, these are again non-final states, and I can merge them, so I don't have to mention anything here. A and B, these are non-final states, and I can merge these two states, so I don't have to mention anything here. Now with the B and F, these are different states. This is final, this is non-final, so I cannot merge them. So that's why when you cannot merge them, then you have to mark those cells. So this is my step 0, so I am writing it x0. Then B and E x0 because I could not merge these two states. B and D, I cannot merge them. Sorry, B and D, I can merge them, so I will not mark anything here. B and C, this one, so again I can merge them, so I don't have to mention anything here. Now C and F, I cannot. Now I'm doing these things speedily, and now you will understand, I think. So this is marked. C and D, okay, these are something same category. I can merge them, so I can keep this cell blank. This D and F, so I could not merge them. D and E, I could not merge them because they are indistinguishable. E and F, E and F both are final states, and I can merge them, so I have to keep it blank. So this is my, now the first step is step 0 is complete. Completed now. And in this step 0, I have seen that there are many cells which I marked with x0 in this step. So when you have something marked in your iteration step, then it means that the next iteration is needed. So now I will perform the next iteration, which is step 1. And now you have to check this step 1. You don't have to check this step 1 in this way, which was which was the step 0 actually. And in step 0 you normally you were checking these things with a very simple logic. But in from step 1 to onwards, you have to leave this simple logic and you have to check the transition over that pair, and then you can decide that either you have to mark that cell or not. For example, now this is something marked, so now I have to check this. These are something marked, so these cells are decided. You only have to decide these unchecked cells or unmarked cells. So now from here and then D, this cell is unmarked. So now I have to check. So what we are doing here, we are basically processing that algorithm, and that algorithm is equivalence of states. This is your undergraduate class, so that's why I am just giving you the practical demonstration of that equivalence of states. Anyhow, so A and D, this is the cell I have to check now in step 1. In step 1, now I am going to check all these unmarked cells 1, 2, 3, 4, 5, 6, and 7. So this is AD. So now I have to check the transition from A to D. So how you can write this, that okay, there is a transition from A to D that you have to check. Transition from A to D that you have to check, and you have to check it because what are the symbols in this diagram. Now you can see here, if you will look on the screen in the DFA, the symbols are 0 and 1. Sigma is 0 and 1. So you have to check your transitions A and D with 0 first, and then with this mark is something like this way for transition and not the dollar sign, and then A and D with 1 input symbol. So I have to check. So now you can check at A with 0 input where you are going in the diagram, that you can see on the diagram. Yes, on A, now you can see on the screen on the DFA actually. I am at A, and by taking 0, where I am reaching B. So you can write this thing here. And then D0. So at D, after taking 0, where you are reaching at D. So this is a new pair that you will get. And now you have to check that either this BD is marked in the table or not. If it is marked, then you can write it, you can mention it with X1. And if it is not marked, then you can write, okay, undecided. So you can write question mark, etc. So now you have to check this BD in the table. Okay. Uh, in this table, now you can see BD. So B and D. So B and D is this cell. This cell is still blank, undecided, undecided. So when it is undecided, then you can put a question mark here. You cannot decide anything, either it is marked or whatever. And similarly, you can check AD with 1. So on the screen at A, after taking 1, where I am reaching at C, and at D with 1, I am reaching at D. So this is the pair. Now you have to check this CD. CD, this is C and this is D, unmarked. So unmarked, then you can write the question mark. And similarly, then you have to check AD is finished, AC. Now you have to check this cell, AC. So transition AC with 0, transition AC with 1. So AC, A after at A0 where you are reaching, I know that it is B. And from C, you can see on the diagram on the screen. From C, after taking 0, you can see from the DFA. C taking 0 where I am reaching, F. F, I am reaching at F, taking 0. So this is the new pair. And similarly here, what is the pair? At A, after taking 1 where I am reaching, C. And at C, taking 1 where I am reaching, D. So this is the new pair. So now I have to check this BF. So BF is here, okay, B and F. This is marked in the diagram. This is X0 already marked, which means that this B and F cannot be merged. And B and F, if B and F cannot be merged, then it means that AC cannot be merged. And here then you can write it with, mention it with X1. This is your step 1. And here CD, you have to check CD. C and this D unmarked, and if it is unmarked, then it means it is a question. This is something you can confirm with here. The things are mentioned here on the screen. So now I am going to move on to the okay, you can check further things. If you look over these screens, so this is X1 at AC, this is AC. You checked AC and it is X1. So A and C here. So here you can mention it with X1. Okay. Okay. You can check further things. So now I am going to remove it because I don't have space. But these things are available in the slides. So AD and AC are checked. And now the next is AD and AC are checked. And now the next is AB. Sorry. A and B with transition 0. A, B with transition 1. So now you have to check this thing on the DFA. Here it is the DFA on the slides. At A taking 0 where you are reaching B. At B taking 0 where you are reaching E. So this is the new pair. At A, I don't know either you are seeing or not. No, maybe. I have seen that it is not visible. So I am just making it more bold. And now at A taking 1 where you will reach at C, and B taking 1 where you will reach D. This would be the new pair. And now you can check BE. So B and E is marked, and if it is marked, I can change this marker also. So if B and E is marked, if B is marked, then you can write it, mention it with X1. And similarly CD, you can check C and D. It is unmarked, so you can write it question mark here. Okay, these are the easy things. Now the next step. So this column is now ended, A, B, and now you can check this one, BD, this one, BD. This is B and D. You can check this one, BD. So dollar sign BD with 0 and then transition BD with 1. Now check it on the diagram. With B taking 0 where you are reaching at E and D taking 0 where you are reaching at D. B taking 1 where you are reaching at D. D taking 1 where you are reaching at D. So ED. So B. So ED. You have to check now this in the table. ED. E and D. I don't have that thing. So you can simply write question mark. BD, which is DD. So DD. DD. So D and D. This one, I don't have that thing. According to the rule, I don't have to consider this one. So question mark. Okay, so this BD is finished. So this BD is finished, and now you have to check this BC. This one, you have to check this BC. Okay, then you can. I have to mark this AB with X1. AB, A and B. So this is my X1. I am going to remove it, so it is very necessary to mark that. So it is F, and these are the lines. Okay. Now, so now I am going to check this cell, which is B and C. So dollar sign BC with 0 equal, it is not dollar sign, sorry, it is delta for transition. BC with 1. So now I can consider the DFA diagram. At B taking 0 where I am reaching at E. At C taking 0 where I am reaching at F. At B taking 1 where I am reaching at D. C taking 1 where I am reaching at D. So now E and F. E and F, it is unmarked, so it means that it is question mark. E and F. Give me something new. E and F. Look at here. Maybe some of you can say that E and F are something the final states, and we can merge them. And then you can say we can merge them, and you can write X1 here. No, you have to check that either it is marked in the cell, like here, E and F marked in the cell or not. It is unmarked here, the cell is blank. So that's why you have to mention question mark, because now this is step number, this is not initialization step. These things you can perform directly only in initialization step. In next steps, you have to check the transition, and then you can decide something. DD is something question mark according to the rules and regulations. Okay, I have done with this BC. So B and C, this is something I have done with BC. And now check this C and this one, this cell, C and D. Okay, C, D, with 0, C D with 1. Okay, now you can consider the diagram. At C taking 0, where you will reach? I will reach at F. At D taking 0, where you will reach? D. Achho. Next is at C with 1, where I will reach? I will reach at D. At D with 1, where I will reach? D. So now you have to check this FD in the table. So FD, I don't have any F, and but F, I have this one, FD and DF is equal according to the rules that we have studied. So this is F and this is D. This is marked, and if it is marked, then I can say it is X1 FD, and DD is something question mark. So what I can write? I can write at CD. I can mark this CD with X1. I can mark this cell C and D with X1. And now I have to check this one. It is E and F. Okay, for this one, I have to remove these things. Now, what is the cell? EF. Here, E and F. EF. So here it is the transition E and F with the 0, and then E and F with 1. Now, with the help of the diagram, at E taking 0, where I will reach? I will reach at E. At F taking 0, where I will reach? F. At E taking 1, it would be E again and F again. So E and F something, E and F something unmarked here in this diagram. So if it is unmarked, then it means that I have a question mark. I have a question mark here. Okay. So now I have only these 3 X1 here. Maybe let's check, maybe someone is left or not. So X1 B C D E F or A B C D E, X1 and then X1. It was marked. This one is marked. Let's check it. This one is okay. So this one BD, B and D. This one BD is marked. Let's check this status again. I can check this transaction. Maybe there is an error BD. So I can write it here. BD with 0 and then BD with 1. So B0, after consulting the diagram, this is the diagram. At B taking 0, where I will reach? E. At D taking 0, where I will reach? D. Okay. Here B with 1, I will reach D. D with 1, I will reach D. So this is something question mark. I know that ED. ED I have to check. E and D. This is my E. I don't have a D, but I can check DE. This is my D. Okay, this one E and D. Yes, this was something the part. So this is E and this is D. As DE is equal to ED, so you can check both of these. So ED is something here, but for E and D is something here, but DE, D and E is this one, and it is marked x0. So you have to, so it is when it is marked, so I can write x1, and in this way BD is something you have to write here, BD as x1. So this was a little bit mistake here. For a teacher it is okay, but for you it is not okay, because you are students, you are learning these things, so you have to keep these things uh, with with quite intention. Anyhow, now this step is finished. Now you, and in this step number one, we have seen that we have marked some cells here. Some cells are still left. So as some more cells are marked in this step, so I need another iteration, which is step 2, you can say. So I have to perform now the step 2. And after removing it, so now what are the remaining blank cells? This one. And what is this cell? AD. So now I have to check again this AD. Transition AD with 0. Transition AD with 1. Okay. Now, according to, with the help of this diagram, at A0, A taking 0 where I am reaching B, D0 where I am reaching D, A1 where I am reaching C, D1 where I am reaching D. So now you have to check BD, BD or DB, BD, B and D. It is marked in step 1. So now it is, when it is marked, so you can mark it with x2. CD, now check the CD. C and D, it is marked. CD is marked, so it is something x2 again. So this, but this is something for AD. So and from this result you can, we can say that we have to mark AD. So this is A, this is D. So now you can mark it with 2. Mark it with 2. Now this cell is left. So you have to check, and this cell is EF. Okay, check this one. Uh, EF. Maybe, sorry, this cell is also blank. I have to check. Anyhow, no issue. EF first. E and F with 1. So now check the diagram. E taking 0 where I am reaching E. F taking 0 where I am reaching F. Same is the case here, E and F. And E and F, E and F is unmarked, so I have a question mark here. I have a question mark here. Now, what is left? Left is this. This cell is left actually. This was marked, and this cell BC, BCD, which I have to check first, but I skipped that. So I am removing this one. What was there? B and C. Okay. So transition BC with 0 is equal to transition BC with 1 equal to. Now check the diagram. B with 0. B with 0 where I am reaching at E. C with 0 where I am reaching F. B with 1 where I am reaching D. C with 1 where I am reaching D. So this is something unknown. E and F is unmarked in the diagram. Final says E and F, this cell. So unmarked, so it is question mark. But this is the step 2, and in step 2 I have mentioned that this cell was marked in step 2. These cells are still remaining. So when we have some cells marked in some step, then it means next iteration is needed. So next iteration, step 3, is needed. And in next step, when I will perform these things on E and F, okay, I can check E and F with 0 and E and F with 1. At E with 0 from the diagram, I will reach E, and same is with F here. I will reach here at F. So this is something question mark, this is something question mark, unmarked here. And then when you will check this one, B and C, so B and C, we know that it is EF unmarked, BC, it is 1DD unmarked. So in this step 3, I don't have any cell marked. And when in any step you don't have any cell marked, then it means that it is the termination condition. Then it means that now the algorithm must have to terminate. We have to terminate this algorithm. So, so these cells are something left unmarked. And what is the meaning of these cells left unmarked? Which means that these marked cells are something that we cannot merge. But these cells which are unmarked after the completion of this algorithm, these are unmarked yet, and it means that we can merge these states. We can merge this E and F, we can merge this F, B, and C. So this is your decision actually. This is your decision actually. I can merge these cells, this B and C, this E and F. And after merging these B and C and E and F in the diagram, then you will have this diagram here. Let's see on this, see this thing on the slides. I can simply remove this. Now, now look over these slides. I have merged the BC and the EF that I was saying. EF both were the final states and BC were the non-final states. So this is something you can simply, after looking over the diagram, you can draw this diagram. After looking over this diagram, B and C, you can merge. Or I can draw this thing again for you on the table if you are feeling some kind. I can on the small board actually. So let's see this thing. Um, so now you have to focus on the slide because I have that diagram on the slide. What are the states I can merge? I know from this diagram I can merge this E and F, E and F. I can merge EF, and I can merge this one B and C. B and C. I can merge these two states. So now look at, over the slides. I have this initially I have this initial state A, and then after merging these B and C, I can draw something and then I can write BC, and these both zeros. Look over the slides, 0 and 1. You can just draw these both 0 and 1 here. That both 0 and 1 going towards B and C because BC is now combined state. And then after that, I can merge E and F. Okay, you can mention from B and C you are going towards. So it is up to you how you design. So I can simply, this is something final state. From B taking 0, I am going towards this E, and from C taking 0, I am going towards F. So only 0. So I don't have to draw 1 here. With 1, where you are reaching, here, this is the D remaining. This is something. With 1, I am reaching a D from B, and from D, from B and C. From B and C with 1, I am reaching a D, which you have depicted here. And from B with 0, you are reaching at E. From C with 0, you are reaching at F. So these edges are complete. These edges are complete, and okay, its own edges 0 and 1, that are just the loops, and on D. So you have to complete all the edges which are given here in the initial DFA, and you have to complete all edges here in your minimized DFA. The decision, the merging of these states BC and EF is given to you by this table, which is the table of equivalence of state. And in this way you can conclude. Okay, now move on towards our slides. Have a look over this. So what I was saying, okay, now this is step 0, which is the initialization. This is the step 1. You have to write all these transitions, and from these transition you can mark x1. This is the step 1. So we have some cell marked in step 1, so next iteration is needed. So when you perform the next iteration, some cells are marked, and since some cells are marked, so we also need the next iteration. And after next iteration, there are no cells which we can say are marked. And when you have this situation, then it means that it is a termination uh, status. And if it is a termination status, now you can draw finally your minimized DFA after looking over this DFA which was given to you initially. So this this is the end of this topic, and this is another DFA given to you, and it is from the book. You have to solve it by yourself. And similarly, this is your homework. This is another DFA, uh, uh, and you have to also solve it by yourself. And then the next topic is about pumping lemma, and I will start this topic inshallah in the next lecture. So until that time, okay, take care. Allah Hafiz.